Hi guys, today I want to discuss the erosion marks of the Great Sphinx and what that might reveal about the intricate history of the Giza Pyramid Complex. The Great Sphinx is situated at the bottom of the Giza Plateau with three Great Pyramids as a dramatic backdrop. One of the biggest controversies of the Sphinx are the deep, vertical rainwater erosion marks on its surrounding walls. These unexpected erosion marks directly challenge the mainstream academia's narrative by indicating that the Sphinx Basin was excavated during a humid time with more rain. About 300 meters or 1,000 feet away, there was the so-called Second Sphinx sitting by the tomb of Khantkas. This Second Sphinx is not an artificial sculpture. It's much rougher and it looks like a naturally eroded sphinx-shaped rock formation. It's interesting to see that similar long vertical water erosion marks also show up near the Second Sphinx, which is additional proof that the Giza structures experienced a previous humid cycle. The Giza area has been extremely dry for 6,000 years with minimal rainfall. Thus, these water erosion marks push the Sphinx age to well before the dynastic Egyptian time. If the Sphinx was carved earlier by an unknown civilization, then what about the age of the pyramids? Are they as old as the Sphinx? Besides the water erosion, there is also significant horizontal wind erosion on the Sphinx and the enclosure walls. It's known that the Sphinx body and its basin were mostly buried since the ancient Egyptian era and had only been completely dug out in the 20th century. How did the Sphinx enclosure walls get the water or wind erosion marks if the basin was filled with sand most of the time? Why would anyone cut out a sunken basin with a rock sculpture in the center on the desert plateau, which would be covered by sand in no time? What can we learn from these different, intriguing erosion signs? In this video, I'll share my thoughts on the water versus wind erosion marks of the Sphinx. I will address whether the water erosion can be caused by flooding, whether the Sphinx was created before the pyramids, and the multi-layered history of the Sphinx formation and how it's related to the Great Pyramids. In 2023, a team of NYU researchers published a paper proposing that the Great Sphinx could initially be a yardon, a wind-blown rock ridge sticking out of the ground, and later reshaped and sculpted into a sphinx. To investigate the Sphinx's shape, the team simulated thousands of years of wind erosion using a mound of soft clay with harder material inside. The experiment eventually generated a sphinx-like shape, and the team suggested that the Great Sphinx might be originally a pre-existing yardon. This is not a new concept. The fieldwork carried out in the 1930s by the archaeologist Emil Barres proposed that the Sphinx was built on two naturally formed yardons located close together. Yardons are mounds of rock eroded into distinctive shapes by wind and sand. They're fairly common features in deserts with strong unidirectional winds. Some yardons are naturally eroded to sphinx-like shapes. Yardons can take thousands to millions of years to form, as their creation is a very slow process of wind erosion that involves the selective removal of softer material, leaving behind harder rock ridges. The Second Sphinx on the Giza Plateau exhibits clear wind erosion signs, and likely a sphinx-shaped yardon of sorts. The head is the darker, harder limestone, and the neck is the lighter and softer rock, which is prone to erosion. If both Giza Sphinxes were originally wind-generated yardons, which is plausible, that indicates they were formed during a very arid period, a period that would not have enough rainfall to leave these severe water erosion marks. So, the wind erosion and the water erosion of the two Sphinx structures took place in separate times, and thus these two sphinxes must have been through a humid and arid climate transition. On another note, yardons often occur in groups called fields. If the Sphinx was a big yardon and the Second Sphinx was a smaller one, then where did the other yardons go? Why there seems to be no more recognizable yardons on the Giza Plateau, unlike other deserts with fields of rock ridges? If the Sphinx was eroded by wind to a yard-on, then how come the limestone bedrock right behind it did not get eroded to a similar stretched long ridges? Could it be that the Sphinx yard-ons at Giza were not solely formed through wind erosion, but instead started from previous rock forms already exposed and separated from the bedrock? By the way, the NYU experiment used pre-shaped mud to begin with the wind simulation. Geologist John Christensen think that the rock walls surrounding the Sphinx, with clear signs of rainwater erosion, might have happened long before the carving of the Sphinx. He stated that the Sphinx enclosure walls are carved at right angles to each other at a height of up to 10 meters, which implies that these walls were man-made. Whether the Sphinx statue was sculpted with the enclosure or not, these high walls and the basin were excavated a very long time ago. It's conceivable that the Sphinx stitch was excavated with a long block left in the center for some reason. The wind then eroded this isolated limestone block to a Sphinx-like yard-on, which later got carved into a statue. The second Sphinx probably started with an excavated rock feature as well, since the aerial photo shows that a block of the bedrock nearby is in a square shape, which is too regular to be formed by nature. Quite possibly, the two Sphinxes both started with previous man-made rock blocks and then were eroded by wind to Sphinx-like shapes. Hence, the answer to why there are only 2 yard-ons at Giza is because the wind did not single-handedly create them. The wind had a big leg up at the 2 Sphinx areas, since prior workers of old had already carved out isolated exposed limestone blocks on the plateau. Now, let's talk about the vertical water erosion marks by the 2 Sphinxes. Some have postulated that the vertical marks at the Great Sphinx came from flooding of the Nile or even the Mediterranean Sea. This is extremely unlikely. The Sphinx floor is between 20 to 22 meters above sea level. The enclosure walls of the west and south sides of the Sphinx are over 30 meters above sea level. Historically, the typical recorded flood heights in Cairo were around 25 feet or 7.6 meters, and the highest documented flood reached approximately 8.4 meters above the normal water level. In other words, the Nile flooding would not have even reached to the low Sphinx floor, not to mention the 10-meter high walls around the Sphinx. To quote Dr. Robert Schoch, the Nile flooding conjecture doesn't work geologically. As for a Mediterranean Sea flooding, that's even more improbable. For the sea level to increase over 30 meters above today's would require significant melting of the Earth's ice sheets. And the sea level change, even an abrupt one, is always a gradual process, which takes centuries to millennia. The last time sea levels were about 30 meters higher was during the Pliocene epoch, about 3 million years ago. And for the last 25,000 years, the sea levels have been lower most of the time, and the Giza area was further away from the shore, thus unlikely affected by any hurricane-caused flooding. As you see, the water erosion marks were not caused by Nile flood or the sea level rise. From photos we can tell that the plateau slopes east towards the Nile, and the north and the west sides are higher than the Sphinx. When it rains, the water and the runoff would naturally flow down. The location, topography, and elevation job of the Sphinx enclosure ensures it would collect runoffs for large areas of the plateau, which means digging a 10-meter deep rectangular basin at the base of the plateau, which would inevitably become a major drainage ditch, was by design. In my prior videos, I hypothesized that the sunken Sphinx Plaza functioned as a stormwater catch basin for the Upper Giza Plateau, where the 3 Great Pyramids stand. One would only design and excavate a big catch basin when there is substantial rainfall and runoff. If the Giza area was as dry as now, with 2.5 centimeters or 1 inch of annual precipitation, the plateau would not have needed a catch basin at all. The existence of the Sphinx ditch and its heavy water erosion marks point to the fact that a concentrated quantity of runoff had drained into the basin. If we look closely, We can also see that there are water erosion signs on the Sphinx. Here are some photos taken before the lower portion of the Sphinx got covered up by bricks. On the Sphinx body, there are folds and vertical features which resemble the rainwater erosion marks on the surrounding walls and the rock core near the second Sphinx. It's evident that the Sphinx itself also sustained long-term rainwater erosion, though in less severity compared with the basin walls. Since the Sphinx body only experienced rainwater but not a collected runoff draining from the upper plateau. The two temples in front of the Sphinx were built with the stones excavated from the basin, which means they were likely constructed around the same time. Some limestone blocks of the Sphinx temple present similar rainwater erosion marks. But the second Sphinx, the 10-meter-high Kent-caused limestone core, also has clear rainwater eroded morphology. All these conspicuous markings suggest that those monuments were excavated in a distant rainier period. So, the Great Sphinx and its basin have endured both water and wind erosions, which presumably occurred in different times. Which erosion, however, came first? Was the humid period before the arid one, or was it the other way around? The correct sequence of the two types of erosions can help us figure out when the Sphinx basin took form initially by finding a matching paleoclimatic pattern. Earlier, I proposed that the wind alone did not carve out the yardans of Giza. The two Sphinx-shaped yardans were produced from pre-existing rock blocks, which were already excavated and isolated from the bedrock. So, the man-made Sphinx basin and a long limestone block in the center came before the wind erosion. The reason to dig a sunken ditch at the low end of the plateau was intended to collect stormwater. The plateau would only need such a drainage element when there is enough rain and runoff, which means the basin is directly associated with a relatively humid phase. Hence, the climate sequence should be humid first, arid second. In a remote past, the Giza region was humid with much more rainfall. Certain construction teams excavated a catch basin at the bottom of the Giza Plateau. They used the stone removed from the basin to build two structures in the front, possibly as stormwater detention and treatment facilities. They also left a limestone block in the center of the basin, maybe as a flow control to manage water velocity or volume. The catch basin worked well for its purpose for quite a while and collected a ton of runoffs, which is confirmed by these deep water erosion marks. Then the climate changed and it became extremely arid. When the region was dry and desert-like, wind erosion became the main type of erosion. The limestone block in the basin was exposed and isolated, thereby having endured much more wind than the enclosure walls. That's potentially how the Sphinx-shaped yardan formed. When it was this dry and windy, the water catch basin turned to a dry ditch, experienced wind erosion, and began to trap sediments. Normally, wind erosion would create the most serious damage at a relatively low height due to the movement of sand particles carried by wind. But the sunken Sphinx basin was different, since its shape would trap and accumulate sand at the corner areas and thus protect them from further erosion. Today, even though the tourist park routinely maintains the site, sand still naturally accumulate at the back and the corner areas of the basin. We can imagine that during the earlier dry period, the lower basin floor would have started to get buried from the corners and walled areas, and in time, the whole basin would be entirely filled with sediments, which helped to protect and preserve the basin walls and the Sphinx body along with the water erosion marks. The possible water erosion features on the most exposed parts, like the Sphinx shoulders and upper back, might have gotten completely worn off or obscured by later wind abrasion. The pyramids on top of the plateau and the megalithic temples in front of the Sphinx were more exposed and would have encountered much more wind erosion. At a certain point, the wind caused damage on the bottom pyramid casings, and the temple blocks in front of the Sphinx became unsightly and might have affected the integrity of the hefty structures. In my last video, I explained my theory that the lower granite casings of the Khafre and Menkaure pyramids and the Valley Temple of Khafre might have been the repair work to patch up the wind-damaged portions. The ancient maintenance team of the pyramid complex collected the eroded parts with more durable materials like granite and basalt. Have you wondered why the Valley Temple by the Sphinx has granite casings, yet the Sphinx and its badly eroded enclosure walls had none? Was it because that the Sphinx and its basin's appearance was not important? Or I think that during the extremely arid phase, when the Giza structures received their restoration work, there was no need to maintain a functional catch basin anymore since there was almost no rain. Plus the catch basin turned to a sediment trap. On a different note, the pyramid repair work seems to be unfinished at Menkaure, considering only small areas of the casing stones were smoothed out. Maybe the project was running over budget and thus done hastily, or maybe the civilization was in decline and chaos, that many projects got abandoned. Since the methods and materials of adding new casings at different Giza structures are identical, it signifies that the pyramids were contemporaries with the Sphinx Basin and two temples in the front. Some argue that the Sphinx Basin with the water erosion marks predates the pyramids by a lot, which I disagree. Here are my reasons. The unique features of the Sphinx Sunken Plaza signal that it was a catch basin. Modern catch basins are designed to collect surface water runoff and direct it into a drainage system. They're typically used in areas where water accumulation could cause problems, such as impermeable surfaces like roads and parking lots, and low-lying areas prone to flooding. Normally, we do not excavate a drainage system for a natural plateau, because natural plateaus and mountains often have their own inherent drainage patterns. Water may percolate into the ground, flow along natural slopes, or evaporate. In many cases, these natural processes are sufficient to manage rainfall. In a relatively humid time, the natural Giza Plateau would have been grown if not covered with vegetation, and would not have needed a man-made drainage system with a large catch basin. Therefore, the existence of the Sphinx catch basin means it was created for a developed Giza Plateau with major impermeable surfaces, thus in need of a drainage system to manage the increased runoff. In short, I propose that the pyramids and the Sphinx ditch were from the same era. The Sphinx Basin might be an auxiliary structure of the Giza pyramid complex, and they were probably all parts of a giant industrial operation, a mining operation. My proposal can explain most of the characteristics of the Great Pyramids, the Sphinx Basin, and certain temples. I made a series of videos diving into the details of this hypothesis, and you can find the list in the description. Okay, so what did we learn from all this investigation? The Sphinx Sunken Plaza functioned as a stormwater catch basin. The severe water erosion marks on the Sphinx enclosure walls were generated by long-term runoff from the plateau, not from flooding of the Nile or the Mediterranean Sea. The Sphinx was possibly originally just a limestone block left in the center of the basin, perhaps functioning as a flow control. At the beginning, the Sphinx Basin and the pyramids were likely created during the same relatively humid time and for the same operation. Later on, when the climate changed and it became really dry and windy, the catch basin dried up and it was inundated with sand. Because the rock block in the basin was taller and stuck out of the basin, its exposed upper portion was eroded to a sphinx form after thousands of years of wind. During this time, the pyramids and other structures also suffered from wind erosion. The pyramid maintenance crew repaired the wind-caused damages with more durable casings. But it seems that the restoration work was abandoned. This might have been caused by the chaos and ultimate fall of the pyramid civilization. After a considerable period, the Giza site was rediscovered and reoccupied by pre-dynastic and dynastic Egyptians. The carving of the Sphinx head might have happened then. One last question. Since the pyramid complex was built during a humid period, and the pyramid civilization likely collapsed in an arid phase, then when would I be? I have some ideas and I will elaborate further in a future video. If you have any insights, please leave me a comment. If you like my video, please subscribe to my channel and share with others. You can also support me on Patreon, which is a monthly charge, or on Buy Me a Coffee. I appreciate your support. This is Curious Being. I'm Tina. Thanks for watching and see you next time.